Hi everyone, my name is Julia and I'll be presenting this research entitled Qualitative Analysis of the Vegetative Solutions After Restoration at the Alto Tijuco Preto lowlands in Brazil. It was developed by myself, Maria Vitória Gomes, and Professor Virgínia Vasconcellos. This work is part of the research group project and environmental representation at the graduate program in architecture of the Federal University of Rio de Janeiro. As we all know and discuss much these days, the urban growth process has led to significant transformations in the natural environment, creating new challenges for city managers. In this context, vegetation is a key element for enhancing the quality of life. However, its suppression leads to reduced infiltration opportunities, resulting in increased peak flows and the loss of river ecosystems. These consequences have increased scientific interest in the multidisciplinary relationship of environmental management in cities, where measures for the restoration of urban rivers arises as an alternative to rebalance human needs and the dynamics of natural elements. So two questions are introduced to develop this work. The first refers to the environmental quality derived from ecological systems in the maintenance of vegetation, while the second one concerns the importance of data availability in the post-evaluation and monitoring of the restoration efforts, especially for rivers. So we talk about remote sensing as a way of collecting information at a distance, which has been used especially to investigate environmental impacts. So this work aims to evaluate the role of vegetation as part of the structural actions for fluvial recovery. In this case, for the Alto Tijuco Preto stream, proposed in 2000 in a master plan for its watershed. It is in São Carlos, in the state of São Paulo, Brazil, and it's presented in this figure. In this work, the Sentinel-2 satellite image provided by the USGS Earth Explorer page was imported to ArcGIS software in order to apply two analyses with a combination of bands, and then to calculate a NDVI index and a moisture index. The arctools used in the software were composite bands, NDVI with the raster calculator, and the supervised classification of the actual and current land use for the year 2020. The polygon that delimits the project was drawn from the area designated as at consolidation of park spaces found in the final technical report for the 2015 scenario. It was converted to ArcMap using Brazilian coordinate system Sirgas 2000. The actual location is in UTM zone 23 South. The combination of bands were used to better understand the features of the images, and they were produced by rearranging the available spectral channels in various ways. The true color band combination refers to bands 4, 3, and 2, and another interesting combination is 8, 4, and 3 to obtain the traditional color infrared image, which emphasizes the differences between healthy and unhealthy vegetation by observing the red color reflectance. And finally, the combination of bands 12, 8A, and 4 for shortwave infrared image that provides variation of the reflected green tones in order to emphasize densities and hence indicate background. So two normalized equations have been done for the NDVI index and the moisture index. The first relates reflectance to the health of the vegetation, analyzing divergent characteristics of dead vegetation compared to healthy existent vegetation. The second normalized equation to find the moisture index focuses on plant water stress for shortwave band 8A and near infrared band 11. Lower values of the index suggest stress due to insufficient moisture, for example. The image classification tool in ArcMap helped characterize the current land use. It was created over the combination of bands 12, 8A, and 4. by pointing out the density of vegetation through different shades of green. As the 2000 master plan indicates different levels of densification according to reforestation needs, the work was based on the indicator as a reference for comparison between the initial goal and the current situation. Due to the small extension of the project and according to the resolution of 20 meters per pixel of the combination band, the quality of the image fixed at a scale of 1 to 5,000 did not allow the classification of the stream itself. In this context, it would be necessary to classify a true color image with better resolution. The Alto Tijuco project was designed by the Department of Hydraulics and Sanitation of the University of São Paulo. It intended to recover the Tijuco Preto stream, located in the watershed with the same name. The watershed was initially divided into 5 sub-areas of 231 acres each, and with guidelines for 6 different systems regarding urban occupation, vegetation, aquatic system, flood drainage, legislation, and environmental education. The vegetation guidelines propose the planting of native species in order to restore ecological aspects, generate greater proximity to the natural aspect of the landscape, and for the opportunity for interaction during leisure activities on a linear park. High density reforestation was proposed for stream banks with no forest cover to protect and maintain ecological properties and water quality. For the marginal areas with public sidewalks, it was proposed medium density reforestation, allowing pedestrian circulation and landscape contemplation. For areas with forest remnants, low density reforestation was proposed, aiming to complement the existing diversity. So guidelines for the aquatic system proposed river management and recovery, considering to reach the most natural state possible. A short-term scenario contemplated the regulation of preservation measures and was considered for the initial implementation of the guidelines regarding the year of 2005. A medium-term scenario indicated the consolidation of the linear park as a strategy to preserve the stream phase implemented in 2010. And a long-term scenario considered the evaluation of the effectiveness of the proposals and the setting of an ecological corridor for the expansion of the recovery of other sub-basins in 2015. It is known that the first phase of the project was completed, including the implementation of the linear park of Tijuco Preto, with measures for recovery of the riparian vegetation. Despite the efforts, there is currently a lack of maintenance that affects the region, which is regularly discussed among local residents. News portals report the disposal of garbage and other objects into the stream, and the invasion of vegetation on the public sidewalk and areas reserved for leisure. This investigation on local press also made it possible to obtain current information about the water quality of the stream. And according to the report conducted in the year of 2019 by the SOS Mata Atlântica Foundation, among 88 waterways analyzed in São Paulo, the Tijuco Preto stream has a poor quality rating. The characteristics resulting from the mapping were compared for the proposed analysis with documents from about the project assessed 2 decades after its development. And for this comparative analysis, the polygon predicted as the area for consolidation of the park in the last phase regarding 2015 was considered. So image 2 shows the supervised classification of land use over vegetative density, where the regions in gray show the areas without vegetation cover that represent impervious areas from urban occupation or dead vegetation. The light yellow shows the regions with low vegetative density The light green shows medium density and the dark green shows the current areas with dense vegetation. According to the proposal established in the mid-2000s, the highest vegetative density should occur in the stream banks without forest cover, and the stream runs from right to left in the map shown, with the left direction being downstream. So differently from what was proposed, the highest density is currently located downstream, along the park road. As explained above, the NDVI index indicates the health of vegetation from the difference in reflectance between the infrared and the red spectrum. So image 3 shows characteristics of the existent vegetation that are not visible to the human eye. In this way, the ecological success of the vegetative system can be noted for almost the entire extension proposed for the 2015 scenario. Image 4 shows a series of soil moisture classes ranging from extremely humid to extremely dry, according to maximum and minimum values. Shortwave and near-infrared spectrum are used to generate that index. However, and according to local conditions, lower values tend to suggest stress due to insufficient moisture in the vegetation. So finally, in the comparison with image 1, image 5 presents the points where vegetation succeeds according to the proposal, highlighted in green, while in red there are regions that did not succeed. So the counterpoints of the proposal that do not appear in green color on the NDVI map are highlighted in image 5. In this case, the formation of the ecological corridors near the stream was not consolidated. The results show that the current situation is more similar to the scenario proposed for 2005 and not for the scenarios proposed for 2010 and 15. This study sought to evaluate the success of the interventions implemented by the Pro Tijuco Master Plan in São Paulo by analyzing revegetation as a strategy for the recovery of the Tijuco Preto stream. The discontinuity of the proposals and the lack of local maintenance presents as an obstacle to its ecological success, since the stream continues to present low levels of water quality. We would also like to highlight the importance of GIS-supported analysis for monitoring scenarios developed with a focus on the ecosystemic improvement. As established with the literature review done in this research, the post-project monitoring and availability of its data, as well as the approximation of the process to the local awareness, is important for its success. Even if all the goals for ecological successes are not achieved, the learning success is fundamental for the continuation and improvement of the techniques of restoration. Thank you.